Welcome everyone. Welcome to Festive Tech Calendar. And this is my session Build an AI web app with Azure AI Search and Microsoft Fabric. I'm so glad to be here with you tonight from wherever you are. Big thank you for watching this video. I am Konstantinos Pasadis. I'm a Microsoft Azure MVP, Microsoft Certified Trainer, and you can find my details here in the links. The solution that we're going to explore today is already hosted in GitHub, and I'm going to show you also parts of the code used for this application through the GitHub repo. So what we're going to use, in fact, this is an application that has a lot of moving parts. The main focus is going to be Fabric notebooks, change data capture using Azure SQL, Lakehouse storage, and of course Azure AI Search and Embeddings with Azure OpenAI. I hope you'll find it quite exciting since the result is going to be a book recommendations engine for personalized recommendations and general generative AI interaction and discussions with our model, of course. The dataset is found on Kaggle, and the solution can be adjusted to really anything you want to use it for. So let's switch to our Azure portal. I'm going to show you all the resources that are used for our application. So let's have a look. Everything is built with Terraform. What we're using? We're using Key Vault. Key Vault is storing all the sensitive information from connection strings to a JWT token that is going to be used for a user profile. We're using Managed Identity, Application Insights, Azure AI Search, an Azure function that is going to be used at the end of our deployment, storage accounts, and of course web apps. So it's quite a big one. Let's switch to the overview since the visualizer is stretching. So you can see here we have our container registry, our SQL database, and I have to highlight here that we cannot use the other than general purpose tier. I have selected the cheaper one, but this is what you can use for CDC to work. Okay, you need to select serverless general purpose. You cannot go with DTU. Okay, what this app does, first of all, it allows you to register your username, and you can find it over the portal. You can register your username and be a part of this identity that is hosted by Azure SQL. It's a custom identity database. Actually, this project started as a custom identity database where user can, they can register and then they can log in and then they can be taken to a dashboard and interact with an AI model. In our case, this is something that has been extended quite a lot. And finally, we have this recommendation engine. Let's start by registering our first user. So it's going to be Festive Tech, right? I will add an age and something that looks like an email address. Okay, let's add our username and the password. As you can understand, it's not integrated with anything. It is a custom identity. Now the interesting part, we can select from a very long list of book genres. Okay, you can hold Control and select your favorite genres and select also your image, your picture, something that you want to have as a profile picture. Upon registration, we have a backend that is very long. It does a lot of things. It is hosted as a Docker image and it is served via Azure Web App. It is an Express.js JavaScript backend that handles registration, login, and the AI interactions. For example, when I want to talk with the AI, the endpoint is handled by this backend. Okay. Again, you can find everything in GitHub under my handle PSSADIS. I'm just showing you a little bit of what's going on while we are running our application. So let's hit register here, and we registered our account. We got a message, and now we can log in. Let's log in and see what is going on in the dashboard, right? What is happening, and the idea of it is to integrate Azure and Fabric. This is the extension of the custom identity database that I discussed a little while ago. So I'm going to log in, and the data, the payload has been sent to the backend, and we have our own dashboard, right? We can log out as well. Remember that we have selected our favorite genres, right? Our personalized likings of book genres. Now, I'm waiting for my personalized recommendations, and I'm going to explain what's going on. But that doesn't mean that we cannot interact with a model. So can you recommend uh, 2 books with war in the description and rating above 4? The dataset that we have in our hands has a book title, the writer, the description, the genre, which can be many categories for each book, so it is not that just a field with a value, it's a multi-value field, and finally the rating. The AI model, through our Fabric notebooks that you're going to see, has created the embeddings for the books dataset, and now it's creating the personalized user profile embeddings that is going to store back to our SQL database. It's going to take some time because we are actually just registered, and now you saw that this thing just changed to your personalized recommendations are ready. And what we have achieved here, we have achieved this very nice function. We can just write the keyword recommendations, and we're going to get our very own personalized recommendations based on our selection of the genres we like. Okay, the code is adjusted to bring only 5 of them, but of course we can ask more questions, and whenever this keyword is into the prompt, the model has a preference over the personalized recommendations of the user. Now this is the front end. This is very interesting, and again you can adjust it to anything and any use case that you would like to use it. It is a React web app. It is containerized, and let's see also the infrastructure and how it is built. We're using Terraform. Okay, Terraform builds most of the infrastructure. Okay, the application inside, the SQL server, the firewall rule for the SQL, the database. We can have also the local provisioner that creates the table for the user, right? And then for the users, okay? Then the storage account, the container, the AI search, the managed identity, and the key vault. Again, the key vault has all the connection string. We are not using environment variables. We're using a key vault client on the backend that gets everything it needs from the key vault in order to perform certain tasks. For example, write the user back to the user database. Now, in Fabric, as you may know, you can start a free trial. It is important to select the trial and then move on to get a capacity. When you get a capacity, you are able to use Spark clusters and run everything you want to run, like notebooks and code and really anything you want to do. And you can see that this is a premium capacity, or as we say, a capacity. We have selected an F64, which is the default when you select a small semantic model as well. Another important thing here for this workspace is the environment. You can create your own environment in Fabric or environments, set them as default for your notebooks, or select different environments for different notebooks, and install specific versions of libraries for your Python, let's say, code. In our case, we have not migrated our code to OpenAI version 1 and later, and we want to stick with previous versions than the 1 version and later. So we are forcing with our environment to stick it on 0.28. The same goes with the search documents, right? This is because we have certain changes in the SDKs and in the APIs as well, and we need to use these specific versions to make our notebooks work. So I'm mentioning the word notebooks. What does that mean? Let's go back to our workspace and see what we have. So this is my workspace. A lot of things going on here. We're going to take it slow. First of all, the CDC event. What does this mean? This is an event stream, right? Created on Fabric, and all that it does, it is watching for any changes in our SQL table, the users table. But we don't want to check everything because we are writing back to the SQL, and you're going to understand why. So we have the ability through CDC and Fabric, of course, to select a specific field to be watched, and only if this field changes, we're going to run this alert, this activation alert, that you're going to see what it does. It fires up a pipeline. So only when this, we show you here through the editor, it is connected to our Azure SQL. It is watching this users table, right? This is the event, and this is the activator that I told you earlier. Let's go back here and see this CDC and what it does. Right? And it is watching through this reflex project. Let me show you now how we can stay within this selection to watch only. This is the event stream, the correct event stream. So yeah, I think. Let me switch to the editor, and you're going to see what I mean. I'm sorry, I have to go to the reflex project. This is the one. So we're telling to our project here, our reflex project, that hey, you're going to watch only a specific, you're going to fire up, I'm sorry, only on a specific condition upon the CDC activation, right? So it is an alert that it is the result of the activation via CDC. And the condition that we're setting is this one. Only when the user ID is greater than 0. So each time a new user registers, the user ID is greater than 0. So in case we need to write something back to our SQL, we're not falling into a loop. This is what's happening with the reflex project and the event stream project that we have activated here. So it is a combination of these two, event stream and reflex, or data activator, as many of you may know it. Again, event stream is looking into the Azure SQL for changes, and it is activating this reflex project. The project has a condition that only the payload of user ID is greater than 0, then fire up this pipeline. Okay, pipelines. Let's see our pipeline. Going back to my workspace. First of all, let's see the first pipeline, the initial one. I got my dataset from Kaggle and I have uploaded into a storage account. But we have a problem here. The problem is that our dataset is not in the best condition that we need to be. It may have different characters. It may have empty fields. It needs some cleaning, some transformation as well, to be stored into Azure AI Search and create once the embeddings. So first thing first, copy from the storage account into our lakehouse. So we need a lakehouse, right? We have named it datasets and lives into our workspace in Fabric. And it's going to be saved as a CSV file. Next is run a Python notebook. Using Spark, we're running a notebook that is cleaning the CSV. It's removing characters that are not in the dictionary. It's removing rows that have empty fields, and it's creating this better version of our dataset. We are storing our CSV to our OneLake back, and this is a format used in the lakehouse, right? You can see here how this is stored, the ID, the book, the author, the description, the genres, and the rating. You can see here that we have very good accuracy on the ratings, which we can also discuss with our AI model when we have logged in into our application. We need to convert our file to JSON, so it will be better, and this is a prerequisite for AI search, to have a better ingestion into AI search, because we have a multi-field into the genres. So another notebook takes care of this case, and it's transforming the CSV into JSON. Copy it back from the JSON to the lakehouse. Okay, we could do this directly in the notebook, but I have preferred to have control over this phase, so I'm storing it back to a specific name, and I know now that in the next notebook that I'm going to transform this JSON into a JSON array, which file name I'm going to use. And that is because when we are storing into the lakehouse, it is using delta tables, and the format is Parquet format. Finally, the interesting things. Uploading to Azure AI Search. Let's go and see our notebook here. You can open directly from the pipeline the notebook. You cannot have more than 10 items in the hub toolbar. You're going to see now that this notebook is using our customized environment. Okay. When you first create your notebooks, you can have magic commands, meaning that you can run pip install, pip install, and so on. You cannot do this when you're running your own book through a pipeline. Just keep that in mind. Okay. You can make your test, install anything you need with pip install, but you cannot do it through a pipeline. So that's why you need environment. So what we're doing here, first of all, we are using our client to connect to our cognitive search, create an index. You can see here our database, ID, title, description, author, genres, and rating. Right? The same exact fields that we have in our file. Just be careful here, the genres needs to be collection, right? And the search data type is going to be string. We're defining the index and we're creating it with these fields. Next thing that we're going to do, again, a new cell. We're creating the search client and we're going to load the JSON data. Some validation steps for our JSON, so we won't fall under an error, and all we have to do is just store it. Okay. We just stored our data to our AI search vector database. Nothing too much of a complex thing. The next thing is the most interesting part, and it's the last part regarding the books dataset. Let's see the notebook. What's happening here? Let me zoom in. You can see here that I have commented out this command. We're connecting to Azure AI Search and configuring the vector search, and we're updating it. So I'm importing specific packages, libraries, creating a client for our OpenAI, and you know why. We're going to use the text embeddings model to create the embeddings. We're defining the index. We are creating 3 new fields. One is the embedding field, another one is the search content field, and another one is the description embedding, right? So these new fields are added to our index in order to store the embeddings and the description embeddings, because this is a field that has a lot of data. So it's better to bring this into a new field. It's better handling. It won't cause you a trouble if you select to go with 2 new fields, but I have selected to go with 3 and a new one for the description. We are creating the vector profile and the semantic profile. And now a very important thing, how we're going to create the embeddings with such a massive dataset. Okay, we are implementing a specific strategy named backoff for the OpenAI API. Okay, creating the embeddings for batch of texts. Okay, and we are trying to the API, we're backing off, and we're retrying. When we reach rate limit, we are stopping, waiting, and retrying. And this is an automated procedure, so this notebook may take a lot of time to complete. Don't worry. It may take 30 minutes. Don't worry. You can see here that we're creating the search content, and we're generating the embeddings for the search content and the description. The search content contains the title, the author, the genres, and the rating, and a separate one for the description. Okay. Two set of embeddings for our book dataset, stored back to the Azure AI Search vector database. We are storing the file JSON to our lakehouse. We don't want to leave it in the memory or in the cache, or leave it in the air, as we say. We're bringing it back, store it for temporarily into our lakehouse, and sending it back to the vector database. So the process is like this. The JSON is in the lakehouse. We're setting the payload to Azure OpenAI Search text embeddings model. We're creating the embeddings, storing them back to our lakehouse, and then we send them back to the Azure AI Search vector database. Trust me, this is a process that I have done a lot of times, and this is the best scenario that I could figure out. Also, I wanted visibility on the embeddings, so storing the file back was my only option. And now we're done with the books. Very rarely you can say that we need to update the content. The dataset is one time, okay? But the users are very dynamic. We have users that are registering into our system. We need to be also dynamic and solve this issue. How we are solving it? We have another pipeline into our workspace. See it? Let me close this because it's going to complain. It is the new users index pipeline. This runs after the Reflex project. Okay, this is what is happening. The new users index, it used to have the store procedure, but I removed it. So we're having this that fetches the user with this very specific query. Okay, we don't need everything. We need the genres, the preferences of the user, and the user ID, of course. So we're creating a joint table, and we're grouping them by user ID and age. Okay. The destination, of course, is going to be our lakehouse again with a different file name. Be careful with the mapping. You need to import the schemas, and if you need to change something, you can do it here regarding the columns. And then we move on to run our notebook. This is a very interesting notebook because it does everything. What it does? It is responsible for create the user's index with the when a new user registers, of course, and update the user's table in Azure SQL. It runs upon the CDC trigger and initiates this pipeline, initiated by this pipeline. So let's see what we're doing here. We are using using an input file and an output file. We are transforming the genres field from a JSON string to an actual list. Okay, writing the transformed data to a new JSON. This is a handling that we need to do. The format is not always the best for this use case. So we need to be careful with the fields and how the data is presented to our Azure AI Search vector database. Again, we're using the text embedding endpoint or model, initializing the search client, bringing the user IDs and the data from the search index, and we're getting existing users, loading user data from the JSON file, validate each document. I'm going to show you also the pipeline that creates the initial user's index, validating the genres, that it is a list of strings, also important. We have users that may select more than one preference, right? We need to do this validation. We're filtering out users that already exist in our index and have the same data, right? Also important. We are uploading now the new or updated users to the Azure Search, and we're generating the embeddings now. The same process goes here, backup strategy, just in case. Just in case. You may have a case where 5 users have registered at the same time or in a very small separation of time between each other. Okay, so when the CDC runs it and catches up 3 or 4 users, you need to be careful and not be rate limited. So we're implementing the same strategy here. We don't need more than one embedding field. We're storing back the embeddings to our lakehouse and we're sending them to our Vector AI Search. A final step is to fire up a function that updates this very nice field in our frontend, and how this is done. It's important to see that also, but let me take you to the first user's creation index, which is another pipeline. Let me show you. We just saw the new users, right? We need also the initial ones. Let's say that we have already registered users in our database. We need also to run this one. So it is the users pipeline. It is more simple. Again, it's fetching the users with the same query, okay? And it uses this new notebook that does also a very important thing. It creates the index for the users. Let's see it. So as you understand, we're using a lot of notebooks. They are very flexible. Of course, they are code, they're Python, and you can do a lot of things with Python. We're creating a new index here, user ID, age, and genres. Again, we're creating the vector profile and the semantic profile. We're creating the initial index schema, the index client, and then we are updating our index with 2 new fields. We're bringing the search content and we're storing and we're creating a new field to store the embeddings. We're updating the index with the new fields, of course, and now we load the data from our JSON file that we just brought from SQL, from SQL. We're saying it here in Greece, SQL. Validation, For the user ID, validation for the genres that it is a list of strings. Again, this is the first time again that this is run for the initial set of users that are already existing into the database. Some logging here, and then we are uploading the documents to Azure Search, Azure AI Search. Next thing, create the embeddings. We're generating the embeddings, backup strategy again, and then we are doing this in parallel with this function to save some time, generating the embeddings from the documents, storing the file back to our lakehouse just for visibility and for better handling because the payload could be a lot of data, saving the documents back to the index. Okay. And now we can understand how this thing was done, how we were able to update, this nice field here. So what we are doing, we are polling our database in Azure SQL every 1 minute, let's say. We can do it faster, but let's say that we're polling it every 1 minute. What we are polling is a specific field. The field is named recommendations ready. So let's see that in the SQL database. Let me go to my query editor. I'm going to connect just with a password. So let's have a quick look. You can see here what happened when you activated CDC. Documentation is very detailed on how you're going to create your CDC and how you can support it, and how you need to do some to create a stored procedure in order to activate CDC for your SQL. So you can see here our SQL database and the table that holds the users. We have user ID, first name, last name, the age, the email address, right? The username, the hash. We're not storing password, we're storing the hash, photo URL, and this is the field recommendation ready. It's not done for every user, but it's done from a point on while I was using this solution. So the first time that we are registering, this is false, right? So when we do the process of the new user's index, and while the user is waiting for the recommendation, this field, the recommendations ready column, right, is false. But when the new user's index pipeline runs, at the end it activates a function. The function, the only thing that it has to do is connect to our SQL and change this field to true. So when we are polling with our backend and see that the recommendations ready has changed to true, we are changing this flag or visual. So we know now that we have our personalized recommendations ready. So let's see once more the whole process while we're watching our resources. Let's change the user to Tech Festive 24, something that looks like an email, TechFest, and the password. Let's select some fiction and some science fiction and some more fiction, I suppose, or something around this. some mystery. I think we are good. And optionally, of course, we can select our picture, our image. Okay, now let's go into the place that we need to follow our infrastructure, and in our case we're going to see the new users index pipeline, and more specific, the new users index notebook. So you can see live what's going on. Of course, you can create. This is the beauty of Fabric, and this is the integration. While we have this application and it's ready, it's working to a certain point, we can of course upgrade it to more enterprise levels, add on security. I don't recommend to use my solution strictly because it is a development version. You need to change certain things. Of course, we have Key Vault, which is a best practice, but you need to switch to private endpoints and all that stuff. So from the run view, you can see all the runs, and this is in real time. So let's switch to the view all runs, and also watch our SQL when the new user is logged in, is registered. Right, this is the field that we're looking to. It's going to be tech festive, right? 24 years old. It's going to be with the ID 34, this user that we're trying to create. Give it a moment. Yeah, this is the history of the runs. This is what happened a little bit earlier, but we're going to see it live. So I'm pressing register, right? Upon registration, the CDC event stream is firing the Reflex project that is in turn firing up the pipeline. The pipeline runs the notebook, and the job of the notebook is to take the new users, create the embeddings for the new user, and run the function that's going to update this field in Azure SQL. Our backend is polling our SQL, and upon change of this field from false to true, it's going to update our flag or our visual that your recommendations are ready. So let's see it. Register our account. Did I press it? No. Yeah. So I'm going to refresh here, and let me log in while this is firing up. It's going to be Tech Fest, if I remember correctly. Sorry, Tech Fest. The username, right? I'm not logging in. I'm waiting for you to see that the notebook is running. The registration has happened, and in a very short time we're going to see the notebook firing up. Yes, this is the notebook that just started. The very first notebook is going to take a little bit more time because the Spark cluster has been into sleep mode, unless we want to be able to run it continuously. I'm not sure how to do that, or if you can do that in Fabric. So I know for sure that it falls for sleep, in um, in sleep after some time. So you need to wait to fire up the cluster so you can run your code. So I'm going to log in now. We know that the notebook is running, but we still wait for our visual. If we look now into our SQL database, I'm going to run the query again. We're going to have a new user 34, and the recommendations ready field is going to be false, right? Now the pipeline is running the notebook. The notebook at the end has a REST API for our function, okay? And the function is going to update this field. to true. Once it is updated to true, our backend is polling this. So it is, yes, it is just updated to true. So in no time we're going to see this as a green one. It depends on how fast or how continuously you want to poll your SQL database. Okay, so if you want very close response time, you need to poll in a continuous manner. If you don't care about it, you can do it every 2 minutes or every 1 minute. It's really up to you. In the meantime, I can write what about some mystery books of rating just around 4.2. Let's see what our assistant will be back. And you see that it's quite fast, right? It's quite fast. And yes, the function was fired up. It is updated as you saw earlier the field, right? That happened very fast, in about a minute. Now the polling again is a dependency that can play its role to how near real time or almost real time you want this update to happen. So upon this, now the user can just write the word recommendations and get personalized recommendations. There are a lot of things that the user can do. For example, they can ask for specific words in the description, as you saw earlier, ask for specific writers, and play with the rating as well. Recommendations is the keyword that the AI model is going to work and find in AI search the specific embeddings for this user based on the recommendations and bring back what it is closer to their preferences. Okay. So we have some fiction and some mystery. I think it's quite close to our preferences. And finally, let me show you the search resource that we're using for our indexes. So you understood by now that we're not using any indexer or any data sources. Everything is done through the data source. There was not used for a test. Everything is done through the API, right? We're doing all the changes, we're creating the embeddings, we're storing them back, we're changing the search with the additional fields, we're creating the search index, right? And there is a very hard detail that I had to find the hard way in the fields. When you want to do this type of very personalized recommendation thing with external data set and all the nice, very nice stuff, to tell you the truth, it's very nice to hear something like this. It is important for your users index. This is what is the important thing, your users index. If you go to fields, the search content needs to be face table enabled. If you try to do this through the AI Studio, I'm sorry, if you try to do this through the AI Studio, you're not going to get the face table checkbox. And this may cause you trouble. It may cause you trouble because you need to find a way to bring the genres, for example, uh, into the embeddings and make them available to the model in order to make the prediction and bring it as a recommendation, of course, in the dashboard, right? So that's why we're using the notebook, and everything is done by Fabric notebooks. So I'm sorry for any small gaps. It's quite late here in Greece. I have to tell you, I wanted to make this video for Festive Tech Calendar, and I'm very grateful for being here and making this video. I hope you like this solution. Again, you can find it in GitHub. I'm always updating the code. There are some minor changes that need to be done in the Terraform, if I remember correctly, but the notebooks are up to date. The backend is up to date as well. Keep in mind, you cannot work this with SQL DTU. You need a serverless tier. Just keep that in mind. I believe that with this information you can build the solution your own, right? You have also the function here, so you can change the solution to whatever you want to change it to. Okay, of course you need to make some changes there in the fields, in the embeddings, and you need to be careful with what you want to make the model aware of, right? So if you want me to help you, if you want me to answer something, if you want to uh, suggest me a better thing or a better way to do something, I'm all ears. Okay, this is something that came out of my very raw instinct of developing. I'm not a developer, and probably if you are a developer, you have understood that I'm not one. But this is my hobby, and I'm very grateful again for being here with you. And I hope again I can see you in another uh, event or a series of events. Festive Tech Calendar is one of the greatest ones, and we are all excited when this time of the year comes. So cheers everyone. Thank you so much for being here today. Have a great one. Bye bye.